Hi, class. This is Mr. Hart. In this podcast, I want to go over what we talked about after we talked about properties of matter, and that is states of matter. So, this is chapter 3 in the book, and we just quickly reviewed over some of the stuff you should have known in your earlier science classes, like sixth grade science, like solids, for example, liquids and gases. Those types of states of matter you should be familiar with, but we're going to go a little bit more deep into this material. Okay, so solids are anything that retain their shape and their volume. They're very rigid, but we can classify them into two different groups. We have the crystalline solids, which are particles that are very well patterned, like you can see here. They have a nice structure to them. Things like salt particles are crystalline structures. They maintain that nice order. And we can compare that to amorphous solids, which kind of don't have any nice order. They don't have a nice pattern, but they're still solid. They're still tightly held together. But things like cotton candy, jello, those types of things that move around more, we call them amorphous solids. Okay. Then we talked about liquids. They, again, don't hold their shape. They take the shape of the container, but they still hold their volume. But we can classify them into two groups, and that is high viscosity and low viscosity liquids. So high viscosity liquids resist flow. Viscosity means resistance to flow. So high viscosity liquids resist flow. They don't take the shape of their container very quickly. Things like honey, molasses, those things that flow very slow have high viscosity, whereas things like milk, water, juice have very low viscosity. Okay. Then of course there's gases, and they neither hold their shape nor their volume. They spread out very rapidly. And so here's just a nice example of a couple of different things for each state: solid, liquids, gas. Okay. Then we talked about plasma, and plasma is one of the most commonly confused type of matter. But a plasma is just like a gas, except it's at a very high temperature. Okay, and so this allows it to become ionized or electrically charged, in other words. So, for example, going back to this plasma ball, these little lightning bolts that are coming out that you can see here, they are highly ignited gas within the plasma ball, and they're charged from that electricity. And so these little bolts are the plasma. Things like lightning strikes are plasma. Or things like stars, for example, are plasma. So this sentence here, since most of the universe is stars, plasma is the most common state in the universe. Okay, since stars make up most of the universe, it's just plasma is going to be the most common because of that. Okay, so let me watch this video down here, which if you want to look it up, I highly recommend it. It's a very good video explaining how plasmas work and how we get these ions, which are electrically charged particles, okay, in the plasma. All right, then we talked about the kinetic theory of matter. Okay, and all the kinetic theory of matter states is that we have matter is composed of small particles, all in random motion. Physical changes in the state of matter result from thermal changes. All that really means is that we have a bunch of particles. Matter is going to be made out of these particles moving around. As we increase the temperature, they're going to change their motion. Okay, so for example, we have the three states: solid, liquids, gases. The more kinetic energy we add to these particles, the farther and farther they get apart. Okay, so the more temperature or kinetic energy, the more distance there is between them. Okay, which is why we get the different states. Okay, so that's the kinetic theory in a nutshell. Then we covered phases. Okay, a change in phase is when a state of matter shifts from one to another. So, for example, we have this fog here, we have this fog here, which is a gas, and it turns into liquid and rains into the ocean or the sea or whatever it is. Right? Any type of change of state is a change of phase. So solids to liquids, liquids to gas. Okay, all those things. And so we have a couple of specific terminology for these changes. So freezing is whenever we go from a liquid to a solid. The most common example is water turning to ice. Okay, when it turns to ice, these particles get closer and closer together, okay, forming this nice crystalline solid. Okay, so freezing, liquid to solid. Okay, then we have melting, which is solid to liquid. Okay, you can think of like a volcano or a forge. Okay, when they're heating the hot metal up, it turns from its solid form into a liquid form that they can use. Okay, then we talked about evaporation, which is liquid to gas. Okay, so you can think of like a hot springs, boiling water. That steam, that gas comes from the liquid. Okay, so that's evaporation. Then we have condensation, which is gas to liquid. So you can think of like dew points and things like that when the water condenses back onto the grass. Okay, this is a cool picture of water condensing back onto a spider web. Okay, then we have a couple of special states which you may have not heard before, which is one of them is sublimation, which is when a solid goes directly to a gas. If you've seen dry ice or a fog machine, you'll see this. They have a solid that goes directly to a gas without taking its liquid form. Okay. Then you have the other direction, which is deposition, which is when gas goes to a solid. If you've ever seen frost on your windshield, that's an example of deposition. Okay. And we can see these changes of states with the simulation. If you want to go to the PhET website, you can look up the simulation yourself and see those changes. Okay. Those are the 6. And you should know how each one of these works and what their terminology is. Okay. This is called a state of matter transition triangle. Okay. And it shows what each term is for each change of phase. So for example, if I'm going from a liquid to a solid, that's called freezing. Okay. I'm going from solid to liquid, that's called melting. I'm going from liquid to gas, that's an evaporation, and so on. Okay, so you should know all 6 of these transitions on the transition triangle. Okay, what the word is from going from each state to the other. Okay, all right. Then we looked at some cool applications of some of these. For example, freezing rain, when water hits an object and goes straight to ice, making some really cool effects on weather. Okay, we talked about forging, which is when they take metal and melt it down or make it extremely hot so that it can be malleable or they can move it around, and then they freeze it back up, and so it takes the form that they need. We talked about evaporative cooling, which is when the water particles on an object, like for example the sweat on your face, will take some of the energy from wind or something else and will start evaporating particles off the top, which will end up leaving the rest of the water cool. Okay, so for example, on your face, when the sweat particles shoot off in all directions, then it leaves the rest of your face cool. That's why we sweat, because of evaporative cooling. We know that it will cool down as the water evaporates. Okay, we also talked about dew points and water rings, okay, for condensation. Okay, dew points with the grass, right? When it gets cool in the night and starts to heat up in the mornings, the water will condense. Glass of ice water, the water will come out around the outside and cool on the edge of the glass, which leaves this water ring. Okay. And we talked about dry ice, which is a cool example of sublimation, and high mountain ranges, which also have this sublimation effect where they go straight from solid to gas. And we watched this video on YouTube, which is a really good video about dry ice experiments. Okay. And how dry ice can go straight from a solid to a gas state, which also has some cool effects. Okay, so we talked about states of matter and phase changes. You should, again, know all the terminology and some of the applications of these. Hopefully that made sense. Let me know if you have any questions, and thank you for watching.